In the area of science and gigantic mysteries, the subject of what existed prior to the enormous explosion has sparked mixed conversations and fascinated characters for quite some time. This enormous question doesn't just test how we decipher the universe. It challenges the actual boundaries beyond which human knowledge can reach. Imagine yourself at the brink of existence, looking into the colossal unknown, observing and pondering the contents before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. But was there a second earlier? Could there have been a condition of nothingness, a calm before the cosmic gathering began? And if this is true, what was it? Or perhaps there was something far more frightening that existed before time itself. As we continue with this inquiry, we are taken on a journey beyond the limits of science, toward insights into the beginning of a universe that test our conscious awareness. Physicist Brian Cox, known for his examination of the marvels of the universe, suggests that surprises may have existed prior to the enormous detonation. He challenges us to reconsider our perception of the world and existence. In this examination, we'll dissect the science, the speculation, and the dazzling insider information that could make sense of what existed before everything. We'll explore concepts like inflationary development, quantum changes, dark energy, and even multiverses. The answers we uncover might just astound you, yet they could also open new understandings of our place in the universe. Get ready to dive deep into a world that goes beyond science and imagination, where the unknown continues to linger in the shadows, shocking scientists and sometimes even unsettling them. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. Understanding the Big Bang. To appreciate what might have existed before the Big Bang, we first need to carefully examine what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extremely hot and dense, growing rapidly to initiate the formation of all matter, energy, and forces. When we look toward the night sky, we see evidence of this hot beginning, with galaxies spreading out in every direction from an early starting point. But why did this happen? Furthermore, was there a period before this dense, hot start? According to the theory of enormous expansion, there was indeed a before, and it was far from empty or tranquil. The theory suggests that before the Big Bang, the universe existed in a state that was cold, vacant, and loose, essentially like an immense vacuum. However, this vacuum wasn't completely empty. It contained a gigantic amount of energy that fueled the rapid expansion of space itself. This extension, called inflation, happened so quickly that it established the foundation for everything else that followed. Space expanded at unfathomable rates until the expansion slowed down and the energy transformed into matter particles and forces, giving rise to the Big Bang. But what was this energy used for? Why did it suddenly cause the universe to grow? And why did it stop? The inflationary multiverse. Specialists believe that this incredible expansion caused each patch of the universe to experience its own Big Bang. Imagine a fabric that extends indefinitely, with minuscule air pockets forming here and there. Each air pocket represents a universe, including our own. This concept, known as the inflationary multiverse, suggests that there are possibly infinite Big Bangs, with no limits, and an endless number of universes. Our universe is just one of many in this vast, perplexing reality. This challenges our understanding of the universe itself and leaves us with the question, what else is out there? The concept of nothingness. The idea of nothingness before the Big Bang is speculative, not proven. Still, according to our current understanding, even if you removed all energy, particles, and radiation from the universe, it still wouldn't be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inevitable tapestry of something, even in its most vacant state. Even if we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality is bewildering to scientists, as it suggests that true nothingness might be impossible. Space itself has properties, rules, and constants that prevent it from being totally empty. Imagine creating a region with literally no particles, no radiation, and no energy. Even then, quantum fields and important constants would continue to exist, suggesting that this nothingness still has properties. For instance, there's a phenomenon called zero-point energy, which represents the lowest possible energy condition of quantum fields. In this state, particles can still momentarily appear and disappear, creating a faint resonance of movement, even in what should be empty space. This challenges our idea of a true void, and suggests that before the Big Bang, there may have been something that scientists are only beginning to understand. The timeless expansion theory. One of the most astounding theories in modern cosmology is the possibility of timeless expansion. If inflation caused our universe to come into existence, it might continue forever, giving rise to countless other universes. Brian Cox discusses an astonishingly vast inflationary multiverse, where universes are infinitely created and continue expanding. Each Big Bang is like a flash, igniting another universe, while inflation continues elsewhere, creating countless more. This cycle, in theory, could go on for eternity. This idea of infinite universes introduces the concept of a fractal universe, where each new universe might create its own Big Bang. Every universe is its own independent domain, unaffected by others due to the rapid growth of space. This hypothesis is both exciting and unsettling, as it suggests a never-ending multiverse with no definitive beginning or end. Imagine our universe as just one small part of a gigantic cosmic structure that never stops growing, continuously constructing new universes. And what if the disturbing reality is that there is no before or after, but rather a timeless pattern of universes forming and decaying? Quantum field theory and virtual particles. Quantum field theory suggests that the universe is not just an assortment of matter floating in space. Rather, it's a complex network of energy fields that fill the universe, connecting to create everything we observe. These fields are like invisible seas, with particles acting as waves. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear within these fields, momentarily acquiring energy before returning it. This phenomenon generates virtual particles, substances that exist for a fleeting moment and then vanish, leaving only a faint memory of their presence. This challenges the idea of a true void. Imagine a universe stripped of all matter, radiation, and energy. Would it be nothing at all? According to quantum field theory, it wouldn't. Fields would still occasionally generate transient particles, suggesting that even in a vacuum, there's still movement and energy. This constant activity suggests that the universe doesn't acknowledge our notion of emptiness. The fields. Gravitational waves are ripples in space-time, first predicted by Albert Einstein's theory of general relativity. They are generated by powerful cosmic events, such as colliding black holes or neutron stars. However, scientists now speculate that gravitational waves might also carry information from before the Big Bang, acting as echoes of a previous universe. If we could detect and analyze these primordial gravitational waves, we might unlock evidence of a universe's pre-Big Bang state. These waves would serve as a cosmic fingerprint, offering clues about the conditions that existed before space and time as we know them. But detecting such faint and ancient signals is no easy task. Current observatories, like LIGO and Virgo, are designed to capture waves from relatively recent cosmic events. To uncover signals from the universe's infancy, scientists are developing more advanced detectors, such as the Laser Interferometer Space Antenna, LISA, which will operate in space, free from Earth's interference. Some physicists believe that these ancient gravitational waves could support the theory of cyclic cosmology. If the universe truly experiences endless cycles of expansion and contraction, then each cycle might leave behind gravitational imprints that persist into the next. Detecting these echoes could provide tangible evidence that the Big Bang was not the ultimate beginning, but rather a continuation of an eternal cosmic rhythm. The holographic principle, a new perspective on reality. Another revolutionary idea that could help explain what existed before the Big Bang is the holographic principle. This concept, rooted in theoretical physics, suggests that the entire universe might be a hologram, meaning that all the information about our three-dimensional reality is encoded on a two-dimensional surface at the edge of the cosmos. If this is true, then what we perceive as space and time might be emergent properties, illusions arising from more fundamental processes occurring on this distant surface. In this framework, the Big Bang could be seen as a shift in the information encoded on this cosmic boundary. Before the Big Bang, the universe's information might have existed in a different configuration, one that we cannot yet fully comprehend. Some scientists propose that this pre-Big Bang state could have been governed by laws beyond our current understanding. For example, string theory suggests that the universe is made up of tiny vibrating strings of energy existing in multiple dimensions beyond the three we experience. Before the Big Bang, these strings might have been in a stable, low-energy state, until a sudden fluctuation caused them to vibrate in new patterns, igniting the expansion of space and time. Quantum tunneling, a universe born from probability. Quantum physics introduces another fascinating possibility, that our universe might have emerged through a process called quantum tunneling. This phenomenon allows particles to pass through barriers that they seemingly shouldn't be able to cross, thanks to the probabilistic nature of quantum mechanics. Some physicists suggest that before the Big Bang, the universe existed as a quantum fluctuation, a temporary disturbance in a larger quantum field. Normally, such fluctuations vanish as quickly as they appear. But in this case, a rare event might have allowed the universe to tunnel from a state of nothingness into existence, expanding rapidly through inflation to become the cosmos we see today. This idea challenges our traditional concept of cause and effect. In the quantum realm, events can happen without a clear cause, making it possible for the universe to appear spontaneously without any preceding conditions. While this concept might seem counterintuitive, it aligns with the behavior of particles at the quantum level, where uncertainty and randomness reign supreme. Brain cosmology, universes colliding in higher dimensions. Another theory that offers insight into what existed before the Big Bang is brain cosmology, which emerges from string theory. This concept suggests that our universe is a three-dimensional brain, short for membrane, floating within a higher dimensional space known as the bulk. In this scenario, multiple brains can exist side by side, each representing a different universe. Occasionally, two brains might collide, releasing an enormous amount of energy and triggering an event similar to the Big Bang. This collision would mark the beginning of a new cycle of expansion and evolution, while the other brain continues its own existence independently. If this theory is correct, then the Big Bang was not a unique event, but one of countless collisions occurring throughout the bulk. Before our universe began, other brains may have existed, some drifting peacefully, others colliding to create new universes. This idea aligns with the concept of the multiverse, suggesting that our universe is just one of many parallel realities, each with its own distinct laws of physics. The limits of human understanding. Despite these fascinating theories, the question of what existed before the Big Bang ultimately leads us to the limits of human understanding. Our current scientific tools and mathematical models are designed to describe the universe after the Big Bang, when space, time, and energy came into existence. But what happened before that singular moment remains a mystery, one that challenges the very foundations of physics. Some scientists argue that the question itself might be meaningless. Since time began with the Big Bang, asking what happened before it might be like asking what lies north of the North Pole, a concept that simply doesn't apply. Others believe that future discoveries, such as a unified theory of quantum gravity, could provide the key to unlocking the pre-Big Bang universe. A journey without end. As we peer deeper into the cosmos and refine our understanding of space and time, the answers we seek may continue to elude us. Yet, the pursuit of this knowledge is a testament to humanity's unending curiosity, a desire to understand not only where we came from, but also what lies beyond the horizon of existence. Whether the universe emerged from quantum fluctuations, collided brains, or a timeless multiverse, one thing is certain. The search for our cosmic origins will continue to push the boundaries of science and imagination, revealing new truths about our place in the vast and mysterious tapestry of reality. Ripples in space-time, brought about by massive cosmic events, are believed by scientists to hold clues about the universe's earliest moments. If early-stage gravitational waves are ever found, they could reveal new insights into those primordial times. These waves might act as echoes of what existed before the Big Bang. Should they be identified, they might provide proof of a universe that preceded our own. The possibility of discovering gravitational waves in their early stages is one of the most intriguing prospects in contemporary cosmology. Such a discovery could not only uncover the truth about the Big Bang, but also offer a glimpse into the cosmic state prior to our universe's birth. Theoretical physics offers a tantalizing prospect, detecting gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what might have existed before the Big Bang, we investigate ideas that push the boundaries of our understanding, challenging even our most fundamental assumptions about space, time, and existence. One of the most fascinating concepts originates from the realm of quantum gravity, which aims to merge quantum mechanics with general relativity. This merger could potentially reveal a unified theory of everything and offer insight into what existed before the Big Bang. According to quantum gravity, time and space are not smooth, continuous entities as we experience them. Instead, they are composed of hidden, granular structures. This theory suggests that the fabric of space-time itself could have emerged from a microscopic plane-scale structure, with tiny quantum fluctuations shaping the universe in ways we cannot yet fully comprehend. In this view, what we perceive as the smooth continuum of space and time may have only emerged from these fluctuating quantum fields. Thus, the state before the Big Bang could be described by a completely different concept of reality, one where space and time themselves lack the completeness we know today. Another possibility is that our universe is part of a vast cosmic landscape of potential universes, each governed by different physical laws and constants. This theory, known as the string landscape, arises from string theory, which proposes that all fundamental particles are actually tiny, vibrating strings. Within this framework, there are countless possible configurations, each corresponding to a different set of physical laws. The string landscape suggests that our universe might be just one of many, each emerging from its own distinct Big Bang. If such a landscape exists, it raises the possibility that other universes may have different strengths of gravity, varying numbers of dimensions, or unique types of matter. In this view, our universe may not be unique, but rather part of a multiverse, a collection of universes, each evolving independently. The multiverse theory offers a hypothetical, yet captivating answer to the question of what came before the Big Bang. Another universe, configured differently, potentially leading to infinite cycles of creation and destruction with no definitive origin. In addition to these theories, some physicists have explored the role of black holes in shaping the nature of the cosmos. One hypothesis suggests that our universe might have formed as a result of a black hole in another universe. In this scenario, the singularity at the center of a black hole could act as a gateway to another universe, with a Big Bang marking the moment when such a black hole gave birth to our cosmos. This hypothesis is supported by the fact that, according to general relativity, the singularity at a black hole center is a point where space-time curvature becomes infinite, causing the known laws of physics to break down. It's possible that the extreme conditions within black holes could lead to the creation of new universes, suggesting that our Big Bang might have been the birth of a universe from the singularity of an ancient black hole. Exploring these concepts requires a deep investigation into the nature of time itself. Some cosmologists speculate that time, as we understand it, may have had no meaning before the Big Bang. If time began with the Big Bang, then there may have been no before in any conventional sense. This perspective suggests that time itself might have emerged from a quantum fluctuation or from a primordial state in which the distinctions between past, present, and future did not yet exist. This idea challenges the concept of causality, which relies on the assumption that events occur in a linear sequence. If time did not exist as we experience it, then the question of what came before the Big Bang becomes nonsensical, as there would be no temporal framework to support such an inquiry. Adding to this complexity are theories of cyclic time. Cyclic cosmology proposes that the universe undergoes endless cycles of birth, evolution, and collapse. In this model, the Big Bang could represent just the most recent bounce in a series of eternal cosmic cycles. These cycles might not be identical. Each iteration could evolve in different directions, with unique physical properties. According to this theory, the universe's cycle is a process with no true beginning or end, resolving the question of before as meaningless. The notion that time itself might be cyclical implies that every Big Bang could be followed by a period of contraction and a subsequent big crunch, with the universe resetting in an infinite loop. Another avenue of investigation into the cosmos is the concept of a primordial soup of fields and particles that existed before stars and galaxies formed. This theory posits that before the universe's rapid expansion, it was filled with a dense, fiery mixture of elementary particles, quarks, leptons, and bosons, interacting at extremely high temperatures and densities. As the universe cooled, these particles laid the foundation for the formation of matter and energy. Some versions of this theory suggest that this primordial soup existed within a realm of quantum foam, where particles continuously appeared and vanished due to the uncertainty principle of quantum mechanics. The properties of this primordial soup may offer insights into the universe's origins and, by extension, what preceded the Big Bang. Ultimately, what existed before the Big Bang remains one of science's most profound mysteries. As our understanding of quantum cosmology and fundamental physics advances, new theories will continue to emerge, providing increasingly complex and sometimes paradoxical explanations for the universe's origins. While we may never fully comprehend what came before the Big Bang, the pursuit of this knowledge will continue to expand the limits of human curiosity, driving us to explore the unknown frontiers of existence.